Okay, on this last video, there are two good problems, a cube and a trinomial with perfect squares. So on this particular problem, this first one, the first thing that we need to do, and we're factoring polynomials, is to set this equal to 0. So I'm going to bring the 216 over, and I have 125 x cubed minus 216 is equal to 0. Always the first thing you look for is the greatest common factor. In this case, I do not have a greatest common factor, but I do have a difference of cubes. A difference of cubes. So I'm going to ask that first question, what cubed gives me 125x cubed? And that's going to be 5x. 5x cubed is 125x cubed. Keep the sign. What cube gives you 216? That's 6 times. And then we're going to SOPs. Square, opposite, product, square. Square, opposite, product, square. And I'm going to do that right here. And I'm going to use this binomial. Don't go back to the original. Sometimes I like to cross it out so I don't accidentally go back up there. So we square the first. That's 25x squared. Take the opposite of subtraction, which is addition. Find the product between the two. 5x times 6 is 30x. And always add the square of the last. The last squared is 36. So here's my binomial times my trinomial. Again, when I go back and I remember, hey, this 3 up here, it's to remind me that I'm going to have 3 answers. Here's this first one. 5x minus 6 is equal to 0. Solve for x. X equals 6/5. So there's my first answer right there. That's an easy one. Whenever you SOPs, you're going to have to use the quadratic formula. You're going to have to use the quadratic formula. These numbers normally aren't very pretty, so we have to kind of go through and work them out. So I have A is 25, B is 30, and C is 36. I'm looking for D. That formula is B squared minus 4AC. So here we go to find that. D equals 30 squared minus 4 times A, which is 25, times C, which is 36. So that D equals 30 squared minus 4 times 25 times 36. Negative 2,700. We do like hundreds though. Negative 2,700. When I go to plug this in, I have x equals opposite B plus or minus square root B squared minus 4AC all over 2A. So here I'm going to go over to the side. I need to find that square root of negative 2,700. So I think it might be easiest just to come right here and say the square root of negative 2,700. I'm looking here and I'm looking for perfect squares. Well, the 100 kind of is a giveaway, so that's negative 100 times 27. I know that square root. What is a factor of 27 that is a perfect square? That's 9 times 3 right here. So this perfect square, or the perfect square is right here, 10i times 3. 10i times 3. That's 30i square roots of 3. So now let's write what we have. We have negative 30 plus or minus, right here, 30i square roots of 3 all over 2 times 25, which is 50. I'm looking right here, got to make a little triangle to reduce. I'm seeing that they're all divisible by 10. So when I write that final answer, I'm just going to come way over here and write it. So x is equal to, dividing by 10, negative 3 plus or minus 3i square roots of 3 all over 5. And here are my 3 answers. Here's 1, and here's the second. And the third. Plus or minus, that's 2, and then that's the third one. So those are my 3 answers. And if I had to write that in set notation, and it doesn't matter which order you write first, if you write plus or minus, this is probably what it's going to look like here. So in the blank, that's how you would write your final answer. Woo! Ooh, those are good ones. Okay, last but not least, I wanted to bring back this example because it's so similar, yet so different from the one that we had before. This is set equal to 0. I want to look for a common factor. In the problem that we had before, we had a common factor of x. In this one, we do not have a common factor of x. We just simply have a trinomial. We have no common factor at all. So therefore, I'm going to set up my two binomials and factor the trinomial. I'm going to bottoms up actually first. Beginning to note first that I have an exponent of 4. That exponent of 4 tells me I'm going to have 4 answers. That is a big key right there. So I'm going to solve this through bottoms up. 9 times 4 is 36. So I have x to the 4th minus 5x squared minus 36 is equal to 0. Set up your two binomials and factor this. The signs will be different, plus and minus. But what I'm going to have here in the first term is x squared and x squared. Factors of 36 that subtract and give me 5 are 9 and 4. 9 is going to get the negative, and 4 is going to get the positive. Remembering that I multiplied in by 9, I have to divide out by 9. So simplify if you can, and if you cannot, you're going to bottoms up. So I have 9x squared plus 4, and then x squared minus 1 is equal to 0. Set each one of these equal to 0. 9x squared plus 4 equals to 0, and x squared minus 1 is equal to 0, and solve. 9x squared is equal to negative 4. Divide by 9. Here, add 1 to both sides, and we've solved for x squared. To undo a squared, you're going to take the square root. And every time you take the square root of both sides, you cannot forget that it is plus or minus. So then we're going to solve. This, also remember here that this is the square root of negative 4 over the square root of 9. So x is equal to 2i over 3. 2i over 3 plus or minus. Don't forget the plus or minus. Then this is equal to plus or minus. The square root of 1 is simply 1. So here are my 4 answers. 1, 2, 3, 4. Plus or minus on both accounts. So when I write that in set notation, I have plus or minus 2i over 3, and I have plus or minus 1. Where you see the 4 answers, if you need to write it, is negative 2i over 3, negative 1, positive 2i over 3, positive 1. There's my plus and minus, and my plus and minus. Either way is fine. I'll take either way. Most students leave it in this manner. So this is factoring polynomials. A little more involved, a little more mature in Algebra 2. Just pay attention to detail, and you'll be fine.